Okay, friends, sige ito sila ay ideal gas equation ng tata. Next time to look at ideal gas equation si gas खरगी combine to रो खरगी combine to si ko combine gas रो हाइड्रोजन सुखाने को जैसे अहमद अखोना करब लो यूज तौगी हागंदा बोल्स लो को बोल्स को नहान से करी नो हागदी वॉल्यूम से गैस के वॉल्यूम से का inversely proportional to gas pressure at constant at constant at constant temperature and amount m. Municipal law na Charles law है Charles law से इसमें कहीं ना कहीं volume is directly proportional to absolute temperature. This temperature is in absolute scale, which is Kelvin scale, and this law is at constant again pressure and m. And another law is Avogadro's law, right? Avogadro's law is में करीब होगा volume gas की volume से directly proportional to n. Number more से हम दे volume यहाँ again this is valid at constant pressure and temperature. So combining these three gas laws, we get combining. Okay, V is directly proportional to temperature and number of moles, and inversely proportional to pressure. So when this proportionality is converted into equality, we keep a constant of proportionality, and in this case, that constant of proportionality is R, capital R. Okay, and this is NT by P. So this R is called universal gas constant. So in a very proper way, we write this equation as PV is equal to nRT. So this is the ideal gas equation. Those gases which follow this equation is called are called ideal gases. Ideal gases. So now from this relation, here R is called what? Universal gas constant. Universal gas constant, and its values are 8.314 joule per Kelvin per mole, or this is 8.314 in terms of SI unit. Joule is also equal to Pascal into meter cube, and per Kelvin per mole is 7. Right. So these are the values of R. This is the value of R in what? SI units, and in common units, the value of R is 0.082. This is in terms of ATM, liter, when the volume is expressed in liter and the pressure in ATM. Okay, per Kelvin per mole is 7. And in terms of what? Bar, this value is 0.083 bar liter per Kelvin per mole, right? And another value of R is 2 calorie, right? 2 calorie per Kelvin per mole. Exact value is 1.98. Okay, but 2 is approximately taken as the value of R in terms of Kelvin. So these are the values of what R in different units, right? So now from this ideal gas equation, we can write more relations, more terms can be reduced here. So here it is. Since PV is equal to nRT, So I can write this relation like this. PV is equal to N is what? Number of moles. So number of moles is nothing but mass upon molar mass. Mass is represented by W and the molar mass is represented by capital M. This is mass and the capital M is what? Molar mass. Mass upon molar mass is number of moles. Molar mass of the gas. Okay. Okay. Now this is RT, right? So this can be again written like this: Pm is equal to mass upon volume. Mass upon volume is nothing but density, right? So I can write Pm is equal to, this is density, which is rho, or I can simply write D. Pm is equal to dRT. This is another form of ideal gas equation in terms of density and molar mass, right? So from here also I can write many relations. From here also I can write many relations. For example, if pressure and temperature are constant, if P and the T are constant, then what will happen? This is constant, this is constant, R is already a constant, right? So molar mass and density, they will be directly proportional to each other, right? At constant pressure and temperature. So constant, then I can write N is directly proportional to D, or this can be written like this also: M1 by M2 is equal to D1 by D2. This relation is used in Graham's law of diffusion or diffusion. That will be the next video of this particular chapter. This is from the statute matter, right? So if this P and T are constant, then M and the D are related like this. Now what will happen if, now M is not constant here, which means this relation is true, is valid for two different gases having different molar masses, right? Okay, and another term is, another relation I can get from this equation is that if M is constant and T is constant, then pressure and density are also directly proportional to each other. So M and T are constant. If M and T are constant, again remember M is constant means what? M constant means I am dealing with the same gas, right? So if M and the T are constant, R is also constant. So I can write P and T are directly proportional to each other. Here I can say P means pressure, okay? Pressure is directly proportional to density. That is, I can write P1 by P2 is equal to T1 by T2 like this, right? This is also another expression. Likewise, from this relation also, I can write many relations. When, for example, number of moles and temperature are constant, then PV will be constant since R is constant, right? So PV constant means P1 V1 is equal to P2 V2. That becomes Boyle's law, right? So from this relation, if only one parameter is constant, for example, if N is constant, for example, if N is constant, let me write here. If N is constant, N, what is N? N is constant, what will happen? PV and T are not constants, for example, then N and the R will be constant. Then P by T, right? PV by T will be constant, which means constant is small k, which means I can write this relation: P1 V1 divided by T1 will be equal to P2 V2 divided by T2, right? This can be used. Okay, please note this. Let me solve a question related to this questions, right? Okay. Let me rough this. Okay. So the question is, if, let me rough it first. The question is, if pressure and temperature of a gas, if pressure and temperature of a gas, fixed amount, gas P of a, let me write here, of a fixed amount of a gas, at 4 liter, hence the volume of the gas at a given pressure and temperature is 4 liter, are the bulk. So the question is, pressure is the bulk, temperature is also the bulk, okay, are the bulk, then what will be the volume of the gas? This is the question. So gas में लेते हैं फिक्स अमाउंट में अदुगी gas की my volume ना क्या होगा 4 liter होएगा अदुगी my pressure और temperature के double होएगा double और 2 times होएगा है निको अदु ऐसे भी question है इसी volume में 4 liter होएगा बतो क्या होएगा कि है भी so let me write the options. Then the options are 4 liter, 2 liter, 8 liter, and 16 liter. Let me choose from these options, right? So let me solve this question. Now we are going to use this relation PV is equal to nRT. So pressure and temperature are the bulk, which means pressure changes, volume also changes, temperature also changes. Volume, let me check. That is to be checked. Okay, volume is changing. Number of moles, fixed amount. Number of moles is not changed. R is constant. So I can write PV by T is equal to constant, which means I can use P1 V1 by T1 is equal to P2 V2 by T2, right? So this is the equation. Now pressure is the bulk, right? Let's P1 is suppose P. This implies P2 will be twice P. Similarly, T1 is suppose this is T, small t. This implies T2 will be what? 2T, like this. I'm not writing the units on it for the units here. So V1 is 4 liter, right? In the question, V is 4 liter, V1 is 4 liter, and we need to calculate, V2, right? So let me put these values in the equation number 1, right? So therefore, equation number 1 implies P1 is what? P. V1 is 4. T1 is T, right? Is equal to P2 is 2P into V2 is 2V calculated. So T2 is 2T. Okay. Now this P and the P cancels out. 2 and the 2 cancels out. T and the T also cancels out. So this implies we get V2 is equal to again 4 liters. So volume does not change. If both pressure and temperature of the gas are double for a fixed amount of a gas, then the volume remains constant. Like this, right? So our correct answer is 4 liters. Okay, let me solve. So what is the length of the video? Let me check once. Then if the length is not so, it's already I think 15 minutes, right? I can solve a question. I can solve a question. Okay, take note of this. Let me take out one question from previous years. Okay, the question is the density of a gas is 1.964 gram per meter cube. Question related from this related to this equation. Okay, so let me write the question here. PM is equal to TRT. Okay, the density of a gas. The density of the gas is. Let me take my book. The density of the gas is 1.964 gram, right? Density of a gas is 1.964 gram per decimeter cube. Decimeter cube is nothing but liter, right? So per decimeter cube means per liter, gram per liter. Okay. And temperature is given to 73 Kelvin and 76 centimeter Hg, right? So the question is the gas is. So we need to identify the gas from this equation. From this question, the gases given are methane, C2H6, CO2, then xenon. This is the question. Okay. So let us solve this question. Okay. Density is given, then temperature is also given, pressure is given. So we need to identify the gas. We need to identify the gas means we need to calculate the value of molar mass of the gas. If the molar mass of the gas comes out to be, for example, 16, then the gas will be methane. And this is 24, 30. If the gas molar mass of the gas is 30, then the gas will be ethane, like that. Okay. So let me rub this portion. Okay. Here is the solution. Here density is 1.964 gram per decimeter cube means per liter. Let me write per liter for simplicity. Okay. And we need to check whether this unit has to be changed or not. Okay. So let me write first. Temperature is 273. It is given in Kelvin, so then no need to change. And what is that? Pressure. Pressure P is, what is that? 76. Right, 76 centimeter. I see. This is in centimeter Ig. 76 centimeter of mercury is equal to 1 atm. Remember, 1 atm. So we need to use this relation because this value of pressure, because R, value of R in terms of atm is known, right? In terms of centimeter Ig, I do not know actually. So let me convert this centimeter Ig into 1 atm because I know the value of R is 0.082 atm liter, right? What is this? Per Kelvin per mole. Okay. So we need to use this relation. Pm is equal to DRT. So gram is okay, liter is also okay, right? Centimeter atm is also okay. Cancel out over gram per mole. Yeah, that's okay. Now, so the m would also say m is equal to DRT upon P, right? So gram molar mass of 81 gram per mole no K का करनी मोल ले होगा ना 40 लीटर सो करनी okay तारे का okay now this is DRT upon what P. D is 1.964 and into RG value is 0.082. Temperature is what? 273 divided by what? P. P is C used 76 180 used only 180. This is the answer gram per mole. Yeah. Sige, say ko na multiply to matanda 273 to the calculator result I have already solved this question. This comes out to be 44. Okay. So this is gram per mole. Gram per mole. Gram ko liter ka करने बाको आपसे per liter में जितने की ATM में ATM का करने. So this comes out to be 44 gram per mole. 44 gram per mole. I have already solved this question. Okay. So 44 gram per mole. So molar mass of the gas is 44 gram per mole. Therefore, 44 gram per mole is for carbon dioxide gas. So the gas in the question would be carbon dioxide. Right? This is of kanangitare carbon dioxide. Okay. Thank you all. I think this video size there again. If you are new to this channel, please like this video, share to your friends, and subscribe to the channel.